Okay, we're going to solve an absolute value inequality now. It's very similar to how you would solve an absolute value equation with a couple of other things you have to think about. So let's take a look at part A. So normally if that was an equal sign, we would set x minus 5 equal to plus or minus 2. Well, now we're going to do x minus 5 is less than 2, and then x minus 5. And this time we're going to say greater than negative 2. Remember, with inequalities, anytime you flip the symbol, you also have to flip the sign. So that's one thing that makes inequalities a little different from equations. You got to remember to flip the sign. If we do that for part B, then we also have x plus 3 is greater than or equal to positive 7. X plus 3 is less than or equal to negative 7. And then you would solve those. But there's another thing you have to think about. You have to worry about, is this an and or an or problem? Because now we have a compound inequality, so we have to know how to connect it. So the way to think about it, like if you look at part A, absolute value, remember, represents the distance. And so we have the distance is less than 2 units. The distance is within 2 units. We want to be in between values, and in between is an and problem. On part B, we want the distance to be greater than 7, beyond 7 units. We want to be, we want to shade on the outsides. It's going to be an or problem. The other way to think about it too is, and this is just kind of an easy loosey-goose way, this is how a lot of students think about it, if it's a less than, think less than. And if it's a greater than, think greater. So you can just look at the symbol also to see if you need an and or an or. On the first problem, part A, it's a less than symbol, less than, we write the word and. Part B, it's a greater than symbol, greater than, greater, it's an or problem. Now that you have that, now we can go ahead and solve it. And so remember, if it's an and problem, you can actually combine your answers. And so we want to be in between negative 2 and 2. So you can actually write x minus 5 in between negative 2 and 2. Just make sure your inequalities face the right way. And then we add 5 onto both sides, so we get 3 is less than x, is less than 7. And then that's it. So pretty easy. If we write it in interval notation, our answer in interval notation looks like that. If we shade on the number line, we want to be between 3 and 7, not including 3 and 7, and so we have that. For part B, this time it's an or, so I can't combine it together, but I am going to subtract 3 from both sides. We have x is greater than or equal to 4. And then same thing here, subtract 3 from both sides. X is less than or equal to negative 10. And it's an or problem. So if I think about the shading on the number line, I want to be less than or equal to negative 10. So I put the bracket on negative 10 and then opening in the direction of the shading. I want to be greater than or equal to positive 4. So again, open bracket opening up the direction of the shading. So I've got 2 intervals that I'm shading on. I'm shading between negative infinity and negative 10, including negative 10. And I'm also shading between 4 and positive infinity, including the 4. So I put the brackets on those. And when you, in interval notation, remember, if you have 2 different intervals, you connect them with a union symbol. And a union symbol looks like a U, but there's no tail on it. And then there's your answers here. And that's how you solve an absolute value inequality.